Hi, I'm Guo Cheng Guang, Thomas of Primary 6. Right now here, we're still having our theoretical mechanics. Now, in our theoretical mechanics, we're at chapter 1. And chapter 1 is kinematics. So in kinematics, right now here we're having some examples for all these lessons. Right now here, these few lessons, we're having examples just to find out whether we are very sure of those types. Like, it can be from the simplest, like positions, displacement, distance, all those, to what we have learned recently, like instantaneous speed, velocity, those different types. So we have to test out each of these. Okay, so let's take a look at what type of example we have right here. So in this example, we are given x is sine t and y is cosine t. So first of all, this type, we can write them into this form. And this type, it is called the parametric equations. Okay, so it is that form. So how about we want to change it into x and y only? So we think about sine and cosine. Think about the different types of identities, and we suddenly get it. We can say sine squared t plus cosine squared t is 1. Yes, this is an identity. But wait, here is sine t. How about replacing it with x squared? Here is cosine t. Replace it with y squared. So you get x squared plus y squared is equal to 1. And this part, it means that it is actually in a circle. And this actually have answered the first part for our locus equation. So what comes out? This circle here. After you have your different axes. Okay, it can be this circle like this. But wait, since this can be just referring to one particle and it moves in this way, so how does this particle actually move? Is it in a clockwise direction, clockwise, or is it in an anti-clockwise direction? Okay, so let's look at these parts. The first thing is the initial part, which is time is 0. So when time is 0, sine will be 0, cosine will be 1. So that means it starts at this part. And in fact, the length of this radius, they're all 1. So down here, -1. Here is also -1. So you can call this a unit circle, if you want to call it. Then next, so time, it just goes slowly and it increases. So let's just say that this point is called A. So let's just say sine and cosine, when it just increases. So sine, yes, it will increase. Cosine, well, it just decreases. So that means it goes in this direction, which is a clockwise direction. So it is like this. Next is for our second part. Our second part, now this, you have to be really careful. Firstly, with this vector, this v vector, it is already referring to our velocity. And in fact, it's only like this. So that means it's instantaneous velocity. And for part 2 and 3, they're all about instantaneous velocity. So at this part, we'll find our instantaneous velocity. So for our instantaneous velocity, we'll have to differentiate them first. So when you differentiate, this part is cosine t. Now here, this t is 1 second. So it's cosine t. But wait, here is for our velocity. Velocity, there is a direction. So we need to know which direction is it in. So firstly, this is x. So you have I vector. So this part is the components in this x direction. Then after that, how about this y? Wait, cosine t, you differentiate. You get an extra negative. So that means here you need to minus. So cosine, then you'll get sine. Sine, well, times 1, you get 1. In which direction? Of course, here y direction. So j vector. And so this part will be the component in the y direction. Okay, so you just get something like this. So the third part, you're going to have something similar to that. So it's just changing from these 1s to 2s. Cosine, yes, as it differentiates, then 2. Then here your I vector. Then still negative sine. Then times still 2. So here, then j vector. So these two parts, they are quite similar. But you have to be aware of when is it. Okay, so then after that, for part 4 and 5, now you don't have that vector. So we're saying about velocity. But here, it is instantaneous velocity. For our part of instantaneous velocity. So, wait. This is for speed, okay? As they don't have a vector before, you have a vector, so yes, it is velocity. Behind, they don't have a vector, so it is about speed. So this part sometimes just gets messed up. So at this part, we're finding for speed, instantaneous speed. Now, in our instantaneous speed, well, we do not have that kind of direction. Well, another way you can write it is actually just, like you can call it the length of this vector, or this velocity for that part. So, to find its length, well, we can use that Pythagoras theorem. Pythagoras theorem. So we get here is cosine 1. Then you square it. Then after that, you add negative sine 1, then you square it. What do you get here? So you have cosine square 1, oh wait, negative, of course, it becomes positive. So you add sine square 1. Wait, isn't it just something like this? Then you just get square root 1, so square root 1 is still 1. But wait, 1 at this part, what kind of unit is this? So for the unit at this part, this is about instantaneous speed. You get meters per second. And why do we choose meters and seconds? Well, of course, we're just using the SI units. So you see that kind of SI units. Okay. Then part 5, V2. Oh wait, V2. Let's learn about this. Cosine 2, sine 2. Isn't it just something similar than this negative, you still turn it into a positive, so you then still add, it is still cosine square something, 2 in this case, then you add sine square 2. So it's still 1. Interesting. This part, at different time, well, they have the same instantaneous speed. They're all 1. And that's all. So maybe we'll learn more about these in those kinds of future lessons, okay? So, but then for this part, at this part, you may want to know a little bit more about this. When do we use it? So like, at which point, what do we have? What can we write it as? Okay, so I'm just going to put it on a separate part. So I just in this open space. Okay, like this. Down here, of course, you have your axis. Then we already have one example over here where it starts from the top there. So what if it starts from here? Then at this part, since it is on a separate graph or a separate of this, we can use A again at this part, okay? But beware, these two are separate, okay? And at the same time, this is also a unit circle. A unit circle, okay. So for this part of A. So for here, we're going to have something about X and Y. But this direction, how about it goes in that direction? Okay, so it goes there. So X firstly increases, then Y will also increases, okay? So for X have to start from 0. And there will be sine. Then of course it is a t. So sine t just gradually increases. Okay, yes it does. Then next part is for y. Now for our y over here, since it is a negative one, it has to be a negative cosine t. It has to be like this. Then after that, when this part 1, then this part gets smaller. So then this part goes up. Okay, something like that. Then how about we have this point B over here. Then after that, it goes in this direction. So this is for part B, okay? In our part B, it goes here direction, in this direction. Still, there has to be X and Y. But beware of this part right now. X, they have this 1. So there will be a cosine. Well, it has to be. So this cosine, then after that, it just slowly goes down or decreases, so it goes back. Then for y at this part, 0, sine t. Oh wait, it goes down. So that means it has to be negative at this part. So these are just like a little bit of example of that. So I hope that all of you are clear so far in this time. So I'm just going to end this lesson here. And if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.